The Thermite reaction, an explosive dive into high-temperature chemistry. The Thermite reaction is one of the most powerful chemical reactions and a fascinating example of high-energy chemistry. Known for its ability to produce extreme temperatures, the Thermite reaction is often used in welding, metal cutting, and even military applications. This reaction involves the combination of a metal powder, typically aluminum, and a metal oxide, usually iron oxide, rust. When ignited, the mixture produces temperatures exceeding 2,500 degrees Celsius, 4,532 degrees Fahrenheit, which is hot enough to melt metal and produce molten iron. 1. What is the Thermite reaction? The Thermite reaction is an exothermic reaction, meaning it releases energy in the form of heat. In its most common form, iron oxide, Fe2O3, reacts with aluminum powder. When ignited, aluminum steals oxygen from the iron oxide, resulting in molten iron and aluminum oxide, alongside an intense release of heat and light. This process can be represented by the following chemical equation.
Fe2O
3 plus 2L2 Fe plus Al
2O
3 plus heat. The simplicity of this equation hides the intense chemical power within the Thermite reaction, which has enough heat to melt through steel and iron. 2. Why is it so hot? The intensity of the Thermite reaction is due to aluminum's high affinity for oxygen. Aluminum atoms readily strip oxygen atoms away from iron oxide, resulting in a large release of energy. Unlike many chemical reactions, the Thermite reaction doesn't rely on external oxygen. It only needs an ignition source to start. 3. Practical applications. Due to its incredible heat, the Thermite reaction is used in a few specialized industries. Railroad track welding. Thermite welding has been essential in joining railroad tracks, creating seamless joints that can withstand heavy loads. Military uses. The intense heat and localized energy release make Thermite useful for disabling equipment. By creating enough heat to melt engine parts, for instance, Thermite effectively disables machinery in the field. Metal cutting and repairs. Thermite is often used for cutting through thick metal components where traditional cutting tools would be impractical or ineffective. 4. Safety precautions. Due to the high temperatures, the Thermite reaction is extremely dangerous if not handled correctly. It requires proper protective equipment, as the molten metal produced can cause severe burns and ignite nearby flammable materials. Only trained professionals should attempt the reaction under controlled conditions. 5. Thermite's place in popular science. The Thermite reaction has become a popular demonstration in educational settings, showcasing the sheer energy that chemistry can unleash. It visually illustrates the power of exothermic reactions, serving as an unforgettable example in many chemistry classes. However, even in demonstrations, strict safety protocols are essential. Conclusion. The Thermite reaction is an incredible display of chemistry's power, harnessing one of the most energetic reactions in a controlled way to melt, weld, and cut through some of the hardest materials. Its combination of simplicity and intensity continues to make it both a valuable tool and an awe-inspiring spectacle in science. This reaction serves as a reminder of chemistry's capabilities, unlocking industrial processes and even contributing to military tactics. Just remember, Thermite might be a mesmerizing reaction, but it's one to observe from a safe distance.